Hi everyone, and welcome to part 4 of a multi-part series. In this video, I'm going to go over how to view the results produced from the equivalent loads created by the RF-DYNAM Pro design module. In this part, I am showing how to view the results of the generated equivalent loads on the structure. If you missed parts 1 through 3, I recommend going back and watching these because the steps in those videos are required for running a response spectrum analysis and thus running the calculation in this video according to the generated equivalent loads. The previous parts 1 through 3 will be linked in the description down below if you're having trouble finding those on our website. So with that said, let's get started. And we can go back to the RF-DYNAM Pro add-on module and take a look at just the brief overview of the input data that we have already entered. So under the response spectra tab here, we have entered the parameters and the standard we would like to generate our response spectrum analysis according to. And then under the dynamic load cases tab, we entered all of the necessary information to generate our equivalent loads, our damping information, and then the mode shapes we want to use to generate these equivalent loads. So now all we need to do is hit OK and calculate. And then once we do that, you'll see that we have all of these load cases generated from the mode shapes from our natural vibrations calculation. And you can see when I click on, for example, load case 4 and show the loads, you can see that at each FE mesh, the equivalent loads were generated and applied to each FE mesh point. So if I turn this into a wireframe view to see these easier, you can see we have our lateral forces and then our torsional force. So if we go into our load cases dialog box here, you can see that the program for each mode shape and direction, it had created a load case, and then for that direction and mode shape, there are two load cases, one for negative torsion and then one for positive torsion. So right now we're looking at the mode shape and the direction X, and then we also have our positive torsion here. So if I go to the next load case, this is for the same mode shape, but then we have our negative torsion. So again, you can see we have about 74 of these load cases, and then we have also our result combination. So the program has used the CQC rule to combine all of these load cases into this result envelope or these result combinations. So we have one for the X direction and one for the Y direction. And then we also have both our 130 rule result combinations. So the next thing you want to do once you see that you have all your equivalent loads generated is run your calculation in Rfem. So you can either just select whatever load case you want to look at or select the result combination. You're probably more interested in the 130 rule, so we could select this one. And then you can hit calculate or show results or hit the calculate all button to run each load case and result combination. So then once your calculation has run, you should see results. So for example, for our 130 rule, we can see our maximum minimum deformations right now. And something I want to show you that you can double check is if we look at the deformations, for example, of our load case 4 for mode shape 1. I'll turn off my loads here, and you should see that the deformations for this mode shape should resemble the mode shape in the table 5.7 effective mass factors. So if we go to that table right now, we can go to table 5, and specifically table 5.7 effective modal mass factors. And if we look at the first mode shape here, you can see that the mode shape looks just like or exactly like the deformations for the results of our LC4 here. So now that we have our result combinations, we want to create a new result combination to combine our gravity loads, so our dead load, live load, and snow load, with our seismic loads, which would be our result combination 4 and 5 here with our 130 rule. And we do this so we can use the result combination for design purposes. So the first thing we would want to do is go to the edit load cases and combinations dialog box. And then we can go to result combination. And we can just simply create a new result combination. So we can name this one whatever we like. Gravity loads and seismic. And then all we need to do is move our dead load over, live load, and snow load. And then according to the ASE 716, we need to apply specific factors such as for the dead load, this is going to be 1.2. Our live load is going to have a factor of 1, and then our snow load is going to have a factor of 0.2. Then all we need to do is move over our 130 rule result combinations. And we want to do this with the OR option here. And the reason we're doing this with the OR option is so then the program will choose between these two result combinations and will choose the worst case scenario and apply that result combination. The program to choose between these two with the worst results and pick the worst case scenario and apply this to our gravity loads. So now all we need to do is hit OK. And then we have our new result combination 6 here, and we can run the results for this. And now we can see our results, and we can use this result combination to design our structure and take seismic loading into consideration. So we can view our global deformations, the internal forces on our members, and then also our surface results as well. So our basic internal forces for our surface, and then some support reactions as well. And so now we can use this result combination for design purposes. So congratulations, now we have fully ran a response spectrum analysis generating our equivalent loading for seismic. And this is now the end of the video and also the series on how to use the DYNAM Pro add-on module and Rfem to run a seismic analysis. And I hope you learned some new things and gained some understanding on how the DYNAM module works. And if you have any questions or comments, you can leave them down below, and I thank you for watching.